So 5 examples, super quick. It's really not like this is anything new. Uh-oh, is it glitching? Holy crikeys. Let me pause this real quick. So anyways, let's knock these examples out now that you can see the 2D. So let's start with, by the way, this program, and I didn't want to go back and change every single one. It doesn't use f of x notation. So basically, we're going to be given a function just in y equals form, and we're going to return an answer in y equals form, just for the record. So it's not very formal, but just understand that when we write this, we're doing f of x. But it's still just the same. The business as usual is still just finding the inverse. So we're going to have 5 to the x power over 3 raised to the power of 1/5. I don't think there's going to be much here in the next 10, 12 minutes where you're going to go, oh, that's new, but there might be a couple little gems or tidbits throughout that will be new. So what do we do first?
Swap signs.
Yeah, we got to swap the signs or the variables, right? So we're going to have x equals 5 to the power of y. I can say from my personal experience of working these out, I tend to keep, you saw me do it in the lecture probably yesterday. I tend to put x in twice. It's like I remember to change one and not the other. So whatever. All right. You know the algebra. What do we do next? Raise both sides to the power of 5. So I'm going to do a side switch on you. I like to do these. So if you raise both sides to the 5th power, you wind up with 5 to the y over 3 being equal now to just a plain old simple x to the 5th. Everybody still good?
Mhm.
What we're really doing is we're just kind of like circling in and trying to close in on our prey here. The prey is this red thing. And, once I get the red thing by itself, then I can go into like logarithm exponential attack mode. So what's the next step? Multiply
Yeah.
both sides by 3. So now we have 5 to the power of y is equal to 3x to the 5th. And then it's time to attack. And this is what I'm curious about. I feel like I got this across yesterday, but it was a little bit into the hour. And I don't know if you were still listening, but how do we do this?
Log.
We log and we make sure that we use a log with a base of 5 so that we can create that redundancy. So if we apply a log with a base 5 to both sides, and because of this number right here, that's our target, obviously, that 5. So I'm going to apply a log base 5. And what that does is it allows the y to just drop right down because a log base 5 of 5 is just cancelville, redundancyville. And then we wind up on the right-hand side with log base 5 of 3x to the 5th. When you check some of your answers, I will warn you about this. And this isn't just a computer thing. Some people are more uptight about it than others. I'm pretty like uptight about where I put my parentheses. The computer will often just leave the argument to the log kind of just out, kind of naked, and I'm not comfortable with that. I feel like if it was just log base 5 of 3, then I'm good. But when it's a clump of stuff, I want to make sure that everybody around is clear that all of that is the argument to the log. So that isn't a thing that you'll have to like worry about. Just know that the computer doesn't do that, but I think we should. Okay. Any questions on that one? All right. We're just going to play a game of can I stump the students? So let's see if this one stumps you. Let's do y equals -8 times log base 3 of x plus 9. And you can see that the argument of the log is just the x and that the plus 9 is not part of that, right?
Mhm.
The lack of parentheses would clearly tell us that in this case. So what's going to be you can switch variables while I'm pouring coffee. How's that? Some nice 3 in the afternoon coffee. So rather than write it all again, I'm just going to put x over here and then change this one to a y. And there, boom, done. So what do we do now?
Minus nine.
Yeah, again, the algebra never lies, right? You understand mechanically that your target is this thing in the red box. Like, I hope I've done a decent enough job with your education to get that vibe, that feel into your soul, that that's what we want to get alone, right? So that we can attack. So -9 and divide by -8. You can do all of that at once, and we're going to do a side switch. So we're going to have log base 3 of y is equal to x minus 9, then divided by -8. And as you go through the answer key, I want to caution you I hope you're listening right now, you're going to see some variations. This negative has decided based on where I wrote it that he's like, hey, I'm going to chill out with the 8. I really want you to hear this because especially like ACT or other sorts of scenarios where you've got to match someone else's answer, there's nothing wrong with taking that negative and pulling it out and applying it to the top. Where we would complain would be if you negativize the top and the bottom, then you're cheating and they offset. But like I wanted to point this out because I know one of the answers in particular, you would see this written as negative x plus 9 over 8. And I want you to understand that those are the same. If you pull the negative off the 8 and fly it up and crush it into the top, do you see how the x becomes negative?
Yeah.
And then the 9 becomes positive? So where you place a negative isn't that big of a deal. I just want you to be aware since you're playing a matching game of how can I get it to look the way my teacher challenged me to make it look. So anyhow, wanted to just say that while it was on my mind. What is the next thing we do? This is the one I thought would stump you. I thought I got him here. So no,
We're gonna have like a 3 with a water.
there it is. It's the water cycle. And you might remember me saying that you'll remember from Algebra 2 that I said water cycle probably about 450 times when we did our unit on logarithms. This is the first one I think we've done where we've had a log and had to undo a log. So what we're going to do is we're going to remember, and I'm just going to show you off to the side. There's a basic relationship that exists with logarithms. We all know that like log base 8 of 512 is 3. And the reason we know that that's a fact is because the water cycle tells us so. We know that if we take the base of a log and raise it to the logarithm, we're always equal to the argument of the log. You should remember that diagram over and over again from logarithms, whether it was 1 year or 2 years ago, whatever. And that's important because, like you said, we're going to take now and raise 3 to the power of this
Yeah.
and set it equal to this. Okay. That's how we're going to free the y from its captivity, so to speak. So our final answer in this problem, believe it or not, it is done, is going to be to say that the inverse y is equal to 3 to the power of x minus 9 divided by negative 8. Without that, you would be stuck right there. That's the moment where you boom, the wheels just spin and you don't go anywhere. It's that relationship that frees us to work. Again,
Nice.
I'm telling you right now, having looked at it, this would be one where the top might say negative x plus 9 and the bottom might say positive 8. So check that and don't feel like you did anything wrong. You just have to write it differently. Any questions there? I thought that one might get us a little bit. Let's try this one, just a simple one. Y equals log of x to the 4th. Again, let's perform the switch. So I'll just change my y to an x, and I'll change my x to a y. There, switch is done. Thoughts on this one?
There's no.
If you try to tell me that we're going to fourth root, I will put the kibosh on that. Why is that 4 not out in the, why can I?
It's part of the y.
Because it's part of the argument of the log, right? So let's be clear. This isn't the log of y raised to the 4th power. It's the log of y to the 4th power. So he's not free to be, you can't go in there and like sneak attack him like that. So I heard someone say there's not a something. What is there?
There was not like a big log.
Do any of you just by some weird chance remember from all of our time together in the past what the base of a logarithm is when you can't see it? Nope. Nope.
No, it's 10.
It is always 10. Remember that we work in a base 10 number system. This all starts to make more sense as you get older. Like the human body has 10 digits. Fingers are literally called digits, right? And there's a reason we have 10 digits in our number system. Like we as humans, if you've ever watched Schoolhouse Rock, there's an episode of that called Little 12 Toes. And I know it's kiddie math, but like the idea of how much different our math number system, our entire metric system, everything humans do would be different if we'd been evolved or born, whatever, into 12 fingers, right? So, I mean, the 10 isn't just coincidence. It's not like someone just thought of that. It's like our entire system is predicated on tens because of right? Ancient people counting with this. So it's really cool to think about. Anyhow, once you insert that base in there, then you're free to water cycle it out. What would this say?
Um,
Remember the relationship. This to the this equals this,
10 to the power of X.
right? So we're going to have 10 to the power of X is equal to Y to the fourth. And I'm going to do a side switch.
I guess.
You want to, when you're finding inverses, the inverse of a log will always be an exponential. The inverse of an exponential will always be a log. And I don't know what the split is on your worksheet, but there's some of each. So log is gone, exponential is here. This should be an easy question to answer. How do we finish this job?
The fourth root.
We take the fourth root. So I will tell you that the answer on the page, I didn't take the exact problem off the worksheet. I just found inspiration from the worksheet. The actual worksheet answer would say this. So let's dialogue real quickly about why that is. Again, the computer isn't wrong. It's just expressing something. I would guess that if I gave this to you on a test, that almost all, if not all of you, would have written your answer like this: y equals the fourth root of 10 to the x.
Yeah.
And I would have no issues with that. Why is the computer doing this?
Because so.
That's all.
Yeah.
That's all it is. And so remember that there's, when you take the fourth root of something, that is literally identical to raising that something to the power of 1/4. Those are interchangeable notations. And so all the computer did was just flip a coin, or maybe someone programmed it to do it that way, but same. So that will be a little challenge again that you'll notice playing the matching game. All right, couple more. Y equals the natural log of the quantity of -5 times 3 to the x. You guessed it. We're going to go ahead and do the old switcherooski. So I'll just put my X over here. I know it's annoying, isn't it? I should just start writing them the other way. And then I'll switch this to my Y. All right, it's go time. Thoughts?
The base E, the power.
The base is E. That's a really important observation. So this might be a really good time for us to get rid of the natural log and write it quite literally as log base E. Great idea. I mean, without that, we really can't crack this open. We can't see it through to the other side. But now we're free. What's it going to say? It's going to say this to the this equals this. Right? I can't stress enough that water cycle pattern is just never up for debate. It's always the way it is. Base to the log equals argument. Whether we're facing left or right, relativity, it doesn't matter. It's the same three people in the same order. Okay, so we're going to say that -5 times 3 to the power of y is equal to e to the x. And we're in a great position here to now start moving in for the kill. There's a straggler. There's someone clinging on that we got to clean. Who is it?
-5.
The -5 has to go. Take a dirt nap. And again, we know instinctively that we can't attack mode until that red thing is by itself. So we're one step away from being able to make the kill shot here. So we're going to say 3 to the power of y is equal to e to the power of x divided by -5. Again, the computer might choose to take that negative and put it up on the e. That's okay. As long as it's not in both places, we're fine.
Let me just get divided by 3.
No.
Oh, wait. Yeah, that's a log. Sorry.
Everybody know the answer to what we do next?
Log 3.
You've got a
Yeah.
log base 3, both sides. Good.
I had them too close.
So the log with a base of 3 creates a redundancy on the left side. Log base 3 of 3 to the blah, blah just always equals blah, blah. So by logging, I can just be done. I can now say y is equal to log with a base of 3 of the quantity of e to the x over -5. And then one more, and then I'll let you work. Sorry, this took a little longer, as it always does, than I think it should, but teaching math takes time. So one more. And have I covered everything? No, I just tried to pick a sampler platter, kind of spread assortment off the worksheet. So you'll encounter some things that you go, new and different, I hope. So this time I'm just switching the variables. Instead of writing y equals, look at me go. Took me 19 tries to get it, but I'm just going to write x equals. I'm switching them right now, dudes. 3 to the power of y plus 10. Man, I should have done that a long time ago. That felt good. That was like cathartic. ¿Qué tenemos que hacer primero?
Times two, -2.
Definitely multiply by -2, right? So we're going to just clean house and get the whole fractionality of this mess out of the way. So if I multiply both sides by -2, I get 3 to the power of y plus 10 equals -2 times x. We're closing in. What's the next cleanup step we got to do?
-10.
-10, right? We got to get rid of the straggler. And so we're going to have 3 to the y. That's our target, is equal to negative 2x minus 10. Next step,
Log base.
log base 3. So you're just going to go y equals. And again, if we were taking a test, we would more formally probably say like f inverse of x, but don't worry about that right now. So just y is fine. So y equals log base 3 of the quantity of -2x. That was an easy one. I thought that one would have a little more meat on the bone. That was a wimpy. What a sad way to fizzle out the lesson. So the rest of the hour today, you can work on the delta or you can work on the worksheet. But again, number 12, challenge issued. Be curious to see what your strategy is when you hit that. Good.
Just one year and do it on paper. Or
I've got the paper copies for you. Yeah.